All right, good evening, athletes. So this is our 6.1 notes, inverse of trig functions. So today we talked about issues of one-to-one and graphs that would have to pass the one-to-one line function test would be a horizontal line test. So we can see that our cosine and sine graphs, we're going to have issues with them crossing at more than one point and not being one-to-one functions. So what we're going to do to utilize this and make them one-to-one functions is we're just going to restrict their domains. So by restricting the domain of these functions for sine, we are going to go ahead and restrict it from here to here and ignore the rest of the graph. So there, by that definition, then we only see that it will cross at one time, and when we graph that function, we can see that we get a one-to-one function where it passes the vertical line test and our horizontal line test, and that will really benefit us as we start talking about the inverse functions here. So this slide should help us have a better understanding of these inverse signs compared to sine. So here in the red graph we have our sine graph restricted in our domain of pi over 2 to negative pi over 2. So by restricting that domain, when we take our inverse function, notice that it's also a function, hence why that other function was one-to-one, and we can see that what was once the domain of our function is now the range of this function and vice versa. Before we could only have a range of -1 to 1 for our sine graph. Well, now that becomes the domain of our inverse function. And that's going to be important to note here. Another thing to important, we'll talk about these if we do the composition of these functions. That our output, because our output is a u, okay, which is an output from our inverse sine graph, is always a angle. So we need to make sure that angle, when we get it from our calculator, is going to be in this u form between pi over 2 and negative pi over 2. Will be our principal value. And the same thing when we do the sine of our inverse sine, where we're going to be between -1 and 1. Okay, so with that note, we can also look at this. So here, as you're going to be asked to find values and angles a lot in this chapter, so we got to make sure you understand what we're talking about. When you say the sine of pi over 3 asks you to find the value, sometimes I'll also say ratio. We got to understand that's a ratio between the two sides of the triangle. If it asks you to find an angle when sine is 1/2, then you know the 1/2 is the ratio and you got to find the angle. So common sense leads us, when you're given one, either the angle or the value, or the angle, you find the value, or if you're given the ratio, you find the angle as well. So if we're asked to find the exact value of y equals sine inverse of -3 over 2, -3 over 2 is a ratio, so we are looking for an angle. So we just want the principal angle, the angle within our range, -pi over 2 and pi over 2. So if you think back to our unit circle, that's going to be quadrants 1 and quadrant 4. Okay, because we should get all values there, because sine we know is dealing with our y values, so we'll get our positive ones in quadrant 1 and we get our negative ones in quadrant 2, and we don't have any repeating, keeping this a one-to-one function. So if we're finding when is sine of theta equal to square root of 3 over 2, we can go ahead and use that bit of information that, well, we are needing to find the angle. So we go to our unit circle and we can see whose sine is the square root of 3 over 2, and we see that it's here at pi over 3. And you should if I also asked you to find the inverse sine of negative 3 over 2, you should also be able to find your quadrant for angle. So for cosine, we are going to do a similar idea, but instead, because cosine is positive and negative in different functions, cosine is also not one-to-one until we restrict the domain. So we're going to restrict the domain for cosine between 0 and pi. Just looking at quadrants 1 and 2, and you can see from there we're going to get our positive values here in quadrant 1, and then we get our negative values here coming from our quadrant 2. Again, when we look at these ideas with cosine, well, the domain of cosine comes from the range of cosine, which was -1 to 1. And if you can see here, when we graph our other functions, so this was our restricted cosine graph, and then we have our inverse cosine graph here, those both being 1-to-1 ratios. So it's going to be important that you have these down in our notes and stuff and understand these. But I think a lot of it is pretty intuitive. You're seeing that what was once your domain from 0 to pi is now becoming your range of your inverse. And what was once your range, see, where's my values? Range. So range here are now going to become the domain of your functions here. So having that mapping idea and that similarity is going to be important, but just realize that cosine varies where it's really dealing with quadrants 1 and 2, where sine was dealing with quadrants 1 and 4. So our principles, when we put them in and we take this out, we are going to get the principal values between 0 and pi and -1 to 1. So how is this going to work? So if we're looking for a cosine that's negative, again, we are restricting ourselves just to quadrants 1 and 2 from 0 to pi. So then cosine we know is going to be negative only in our second quadrant. Okay, so where is cosine -2 over 2? Well, that's with the reference angle of pi over 4. So in quadrant 3, when this angle is pi over 4, we know we're talking about 3 pi over 4. And we can see that this inverse cosine is asking for an angle measure. And also, again, if this was positive, should be prepared to also be able to tell me what the inverse cosine of square root of 3 over 2 in this same interval as well.